Okay, I think we're getting ready to get started here. Welcome to the next in the series of Wednesday webinars provided by Exida. This is a regular service that we provide to our clients and people interested in the services that we provide. Our session today is on cyber program management. My name is Dave Johnson. I have a little bit of bioinformation which I'll share with you shortly. You will all be muted during the presentation, and if you have any questions, please type them into the question box, and I will try to get to them, if not during the presentation, afterwards. So, again, welcome. We're talking today about cyber program management. A little bit about Exida to start out with. We are an international organization with offices around the world. This broadcast is coming to you from our Sellersville, Pennsylvania office in the United States. But as you can see, we have a number of offices in Europe and in the Far East, Africa, South America. So we do have a presence around the world. Our industry focus is on automation, the process industry, automotive, and nuclear. Our involvement in nuclear activities is a little bit limited at this point. Primarily, we're involved in automation and the process industry. We do work with original equipment manufacturers, system designers, engineering contractors, and end users from the standpoint of training, certification of processes, as well as products. There are quite an extensive range of services that the company provides: consulting, engineering tools, product certification, training. This webinar sort of falls into that category. Reference materials. We have a number of databases on failure information, textbooks. I'll show a little slide about that in just a moment. And professional certification. The top of the list there is Certified Functional Safety and Expert. So I'd encourage you to take a look at our website. There is a wealth of information there on both safety and cyber topics, and don't hesitate to contact us if there are any specific needs or things that we might be able to help you out with. In terms of certifications, we are the largest safety product certification agency in the world. This is what a safety certification looks like. There are a number of aspects of this that are identified within the standard IEC 61508, which is a safety specification. But as by way of example, we do certifications to IEC 62443, which is the recognized international standard for cyber-related activities. I did mention that we have quite a variety of books available. The SCRH text that you see at the bottom are databases that are used during our reliability engineering studies. So again, I'd encourage you to take a look at those. They're available through Barnes & Noble, Amazon, any place you can buy text book information. There are a number of engineering tools that we have here. Excellentia is our flagship product, primarily focusing on safety and reliability engineering. If you look there in the bottom left, CyberFacts, there is an extension to Excellentia which specifically deals with cyber risk assessment. Again, if you're interested in the tool, send me an email or contact us, and we'd be glad to give you some further information on that. My name is David Johnson. That's my contact information there, djohnson@exida.com. I have a MSCE from Villanova, BSCE from Penn State. I've been in software engineering activities for quite a number of years. My title here is Senior Safety and Cyber Engineer. I work with teams and organizations in certifying their processes and their products, primarily to 62443. I conduct training classes in many of the standards, and I participate in a number of the international committees on cyber identified as part of the 62443 series. So let's get into this. Cyber program management. Actually, it's more formally known as Cybersecurity Management System. We're setting up a Cybersecurity Management System, CSMS, and it refers to how organization manages its perceived security risk. So it typically looks like a collection of policies and standards and guidelines within an organization, perhaps some specific working procedures or document or process templates. And these are all put together in a unified set to define the activities within an organization and specifically how they deal with cyber risk. It's very important that once these procedures and standards are in place, that all the staff and personnel within the organization clearly understand those policies and how to use them. But more appropriately, or more importantly, is the development of an overall cyber risk mindset within an organization. It may be convenient to do things like share passwords, but that is probably one of the most fundamental ways in which systems wind up getting breached. So there has to be a mentality within the organization which is oriented towards protecting against cyber attacks. Fundamentally, in many organizations, you do have a conflict. In manufacturing environments, there are the parts of the network which deal specifically with the control systems, and then of course there's the general IT side of things that manages the business. From an IT perspective, confidentiality is the primary goal, the highest characteristic of the system that IT is concerned about. You must remain confidential, keep personnel records in place, processes in place, and any other company information. Certainly there is integrity and availability are concerns, but confidentiality is the highest priority. Whereas if you look at things from a control system perspective, availability is really the most important aspect. You must always be able to view and maintain the control of your process. If you ever lose that, then you don't know what's going on out in your manufacturing sites, and you could perhaps be blind to things that are happening, and that always is a potentially extremely dangerous situation. So availability is the most important thing from a control system or an operational standpoint. Certainly integrity and confidentiality are important also on the operational side, but making sure that your system is available is of primary importance. So you can see inherently within an organization there is this conflict that exists. So when you're putting together your cyber management system, you need to bring both teams, all parts of the organization that deal with networking, network connections, or any applications that run on your network. All those teams need to come together and hammer out these differences that exist within the organization. So again, setting up this system is one of your greatest challenges. So why is industrial automated control system security important? Well, consider the fact that this equipment is communicating with real-world devices. I mean, these could be tanks and vats of dangerous chemicals, possibly explosive kinds of materials. You want to make sure that you're tightly connected to and can see and control everything that's going on. Any kind of cyber attack that occurs on a control system could potentially lead to serious situations. You could cause injury, there could be fatalities, environmental consequences, spillages and leaks. There could be loss of production, or perhaps potentially equipment damage. We'll take a look at a situation where that occurred in a German steel mill about 2 years ago. You could also potentially produce off-spec or even a dangerous product. So attacks can be quite serious on any given system. One of the ways that I like to think about this is if you have a safety system in place and you're protecting, let's say, a large vat from explosion or overheating, and you have a safety integrity level 3, let's say. The safety integrity levels, for those that aren't familiar with them, run from 1 to 4, the 4 being the highest measure of risk reduction that you can achieve. So if you have a safety system in place, let's say that's SIL 3, that has anywhere between 10 to the minus 3 and 10 to the minus 4 risk reduction within your environment. So you need a commensurate level of risk reduction when you introduce your cyber solution. So you need to make sure that you understand, certainly within any kind of cyber solution, there are different ways that things can be implemented. I'm going to show you a number of documents where guidance is provided for taking a look at varying levels of security and security risk reduction that are needed. So certainly you would need security level risk reduction on par with the safety integrity level risk reduction which you've previously identified. So from an overall process safety management perspective, as compared to the cyber side of things on the left side there, you can see that under conceptual design and scope, in both cases, one of the main initial activities is a hazard assessment, process hazard assessment, both from the standpoint of the perspective of safety and also from security. You want to make sure that you clearly understand, certainly from a safety perspective, what your hazards are, what kinds of spillages or over temperature situations that occur that could be dangerous. And then from a cyber standpoint, what are your points of attack? Where are you vulnerable? What kinds of things you're vulnerable to? And then from a design perspective, on the security design, you're looking at all those potential attack vectors and coming up with a design that is going to protect you against those. Then you implement the design and operate and maintain that environment, constantly testing to make sure that you are in fact still secure. The National Institute of Standards and Technology, NIST, came up with a framework 2 years ago that does a very good job of describing in sort of general terms all the kinds of things that an organization really needs to think about. It's split into 5 categories, starting with the upper right at identify. So identify what your potential dangerous attacks could possibly be, protect against them, put together some kind of a detection mechanism, coming up with ways and processes to respond to attacks, and when, and it's pretty much inevitable that you are in fact attacked, what kind of recovery mechanisms do you have? So both of these, the flow chart on the left describes the various phases of setting up and conducting the cyber analysis and setting up a protection. And on the right is the NIST framework, which shows what the basic processes are that are put in place in order to achieve that. So initially, from a cyber perspective, you're looking at ways in which your system can be attacked. Certainly direct connection to the internet through your business, hopefully through a firewall. That's a possible point of attack. USB ports are also a very widely used form of attack. If anyone is familiar with Stuxnet, that is the way in which the control systems for the uranium purification in Iran, how those were attacked and selectively disabled. There could be misconfigured firewalls. This is potentially a training issue. You could identify that you need firewalls in certain parts of your business network, but if they're not configured correctly, in other words, the people who are responsible have not been adequately trained, those firewalls could potentially be set up incorrectly, in which case they're not providing you with the protection that you think you have. There are potentially external programmable logic and control networks that are connected into your system. There could possibly be an infected laptop, which someone takes home, opens up an email message, winds up getting his laptop infected, comes back in, plugs it into the business network or the process network, and releases a virus. Wireless access is also something that needs to be considered. There could very well be situations where a remote support or remote connection is impacted. The one most recently, actually it's not that recent any longer, but when Target was attacked, the Target retailer, that came through a vendor of theirs. They were had connections to the vendor's system. The vendor system was infected, and then through the connection to that vendor was not sufficiently secure, so the vendor was able to, the attacker that infected the vendor's system was able to get in and attack the corporate headquarters. There also could be I/O networks connected to your system. So this is just a short list of possible ways. There's a diagram here that shows where what this might look like if you have, let's say, an office or a business LAN, which is the topmost LAN, and that goes to the next level is the plant network, and then from the plant network connect down to the actual controllers and I/O subsystems. You can see cases every time you see one of those nasty-looking alien faces that represents a possible point of attack. You know, starting with the upper right, infected remote support. There could very well be devices that have authorization, capability to get into your system, but become infected. Modems, a wireless connection. You could have an infected laptop right there in the middle that you bring in from home after it being configured or infected. You see there on the left side the USB ports, and that actually applies to any one of the devices there. Viruses could easily come in on USBs. Down at the bottom, there's an RS-232 link. It looks like, in this case, it's set up to some kind of a remote device. Again, if that device is somehow infected, you know, it has a USB port or perhaps an internet connection, it becomes infected. Now you have a direct line right into your control system. Any external networks there on the lower right that might be also connected in your system may very well themselves not have adequate protection. And now that you're connected to those through your system, that could create a very serious situation for you. You know, it provides yet another avenue of potential attack. So let's take a look at what does it mean to actually attack a safety system. So if you have a basic control system in place and your system is operational, that control system should be doing what it's supposed to do in terms of controlling the process and handling process upsets. So if for some reason that basic control system doesn't function correctly, then there's the concept of the safety system, which is looking at the most critical aspects of your process, and it takes over and drives the process to a safe state. So if your safety instrumented system or safety instrumented function is specifically attacked because, like the rest of your process, it too is connected to some kind of a network or a process control network. If it's attacked, and disabled, now your process control system has no protection in place. So theoretically, if your basic control system is attacked, the safety system can respond to deviations in the process and create safe conditions or return your process or environment to a safe state. Whereas if the SIS or SIF is attacked, there is no protection. And then if something goes wrong with a basic control system, you have a potentially very, very dangerous situation. So this text is taken from the ISA technical report 8409. That is, there's a team which is currently actively working on this, and they expect to be able to release this report in a few months. So this particular report has some very significant information on doing risk assessments and taking a look at functional safety systems and how they can be potentially attacked. So this is one very good resource. Now, I mentioned earlier the IEC 62443 series of standards. This is probably the most widely used, widely consulted set of standards in the industry. It's divided into 13 parts. They're broken down into, as you can see on the left, general policies and procedures, systems, and components. And what they do is they provide guidelines in each one of these areas. Now you can see from the legend on the bottom there that some in fact are published, some are going through new revisions, some are still in the works, and there are some that are still sort of pipe dreams. The use cases, IEC 62443-1-4 in the upper right, there hasn't been a whole lot of traction on getting these use cases set up. Same way with 2-2 right in the center there. There is preliminary work going on, but the standard is not well established. Now, if you look at down in the lower left-hand corner, the 4-1 and the 4-2 standards are both very close to being released, and these have direct impact on manufacturers and guidance that they can specifically and directly use in terms of designing their equipment and their components. From a system perspective, 3-1, 2, and 3 all provide good guidance on how to set up systems. 3-2 specifically has some very good guidance on risk assessment. So if you're just starting out in this process and trying to understand what risk assessment means, and you have some sort of or a network currently in place, I'd recommend looking at that standard. It helps you understand the risks that are involved and also means for partitioning your system into what are referred to as zones and conduits. The 3-3 spec looks at foundational requirements that are key for any kind of a cyber environment. Deals with management of users, authentication, and a variety of other specific functional topics. So in terms of a guidance, 62443, like I say, is an international standard, widely recognized, and is a set of standards that organizations can be certified to in a variety of through a variety of these standards. Now, there's also a guideline or a framework that was put out 2 years ago by the National Institute of Standards and Technology, and it's referred to as the NIST Framework. This divides general organizational operations and policies into 5 different categories. Those dealing with identifying issues, protecting policies to protect an environment, policies to detect attacks if there or viruses and things that are cyber concerns or vulnerabilities that are present, how to respond to those, and when, as is virtually inevitable, you are attacked, setting up policies to recover from those attacks. So one good example is if you are infected by some sort of a ransomware and you have regular backups in place, you should theoretically not be concerned because you just wipe the systems that are infected and restore a recent backup. Depending on what your backup cycle, you may lose a limited amount of information, but it should not at all be catastrophic to the organization. So let's take a quick look at both of these together. The NIST Framework on the right and 62443 on the left. And you can see from policies and procedures and a system perspective that NIST does cover a lot of those areas. NIST doesn't necessarily deal specifically with components and component functionality and processes, but deals a little bit higher in the organization in terms of policies and procedures, and also from a system perspective in terms of architecture of the delivered system. So 2-1 that we saw in the diagram there, 62443 2-1, is the clearest or the best resource when it comes to cyber program management. And this graph or flowchart here breaks down the major components of the 2-1 standard. So it starts out with a risk analysis, then it combines and addresses that risk within a cybersecurity management system, and then identifies ways for monitoring and improving the CSMS. So from a risk analysis standpoint, you need to be clear on your business rationale, classification of risks, identifying assets, making sure that you're very clear as an organization as to what is important and what's critical within your environment, potential ways of those assets being attacked. So that's all part of the risk analysis. And again, as I mentioned before, the 62443 3-2 does provide some good guidance there, as does the NIST framework in terms of organizing and conducting a cyber risk assessment. So once you have the risks assessed, you want to make sure that you're clear on what the scope is, set up organizational security entities within your organization. Make sure your staff is trained and is cyber or security aware, that you have business continuity plans that are in place, such as rapid recovery in case your system is seriously infected. And these are all governed by the security policies and procedures that you set up as part of the CSMS. So there are countermeasures in general set of countermeasures that can be put in place to protect against attacks and possible attacks on your system. Personnel security, do you have badges and passwords and the like systems in place? Is there good physical security within your environment? Network segmentation is also key. If you have a flat network, any drop or any device on the network can talk to any other device. This is probably not a good idea because there are very likely different segments that have a need for a higher degree of security than others. So you want to do something in terms and use some mechanism to segment your network. You can set up virtual private networks. You can use switches and routers and firewalls, all to break up your network and protect those parts which you deem to be the most critical and most secure. You need to have good access control, administration and authentication, and any authorization surrounding changing those administration and authentications. So And then from an implementation perspective, you know, a good plan in place, what kind of maintenance is needed. You need to be able to document all these processes and set up some kind of an incident response planning. So these are the major areas. And then, of course, once you have this all in place, you want to make sure that you stay compliant in terms of monitoring and improving the system, record things that don't go well or are problematic, and feed that back in so that you can improve. Certainly, if any attack occurs, do thorough analysis of that attack, and so you can feed back, you know, understand the nature of the attack, where it came into your system, and how you might be able to prevent that kind of attack from occurring again. So these are the basic components that go into a security management system, and they're all very well described and described in the 2-1 standard. So here is, again, taking a look at 2-1. We looked at the overall series of documents and mapped that to NIST. There is actually a much closer connection between the NIST framework and the 2-1 standard. You can see on the right-hand side there, NIST is actually divided. In a previous slide, you could see that there were different functional areas that were divided into categories. These are some of the categories that are associated with each of those sections. Again, the main sections within NIST: identify, protect, detect, respond, and recover. And within them, identify, as we discussed, you know, do your initial asset management, understand your business environment, what kind of governance you have in place for managing, coordinating all that, do your risk assessment, and come up with a risk management strategy, and so on through other parts of the standard. NIST does divide the basic functional areas into categories and subcategories, and also provides a significant amount of specific references that will help further understand and implement these various categories. So if we take a look at how that maps over to 2-1, we can see the colored arrows are associated with virtually all of the, or in fact all of the activities there. So in one way or another, NIST is providing specific guidance on each one of those areas. So by looking at both of these documents, they both become very good references as to how to get your system set up. There are also basic concepts when it comes to setting up your security environment. There actually is a one-day course that exida provides, which goes through these 7 steps in detail. But just as a quick review here, as you've seen, or as I've mentioned previously, down at the bottom, you want to assess your systems. You want to make sure that you have a very clear picture of the inventory of what equipment out there that is attached to your systems and what you're specifically trying to protect. You have to make sure that policies are documented. Everyone agrees on the current means for managing those assets. Trained personnel, very, very critical. Personnel has to understand how to do their jobs, how they fit into the organization as defined by work procedures and policies, and they have to have the specific skill sets. If you have people that are responsible for setting up firewalls and they don't understand how firewalls work and how to set them up, the firewalls are basically no good to you. You want to next segment your control system network. We mentioned this earlier in terms of setting up zones, higher security zones. Conduits are the connections between the zones for purposes of further isolating critical assets. You want to make sure that you're clear on the responsibilities and who has access and how that access is maintained, the control access step there. Then you can start taking a look at the various components with your system and what you might be able to do to actually harden those components. So you can take further action to secure them. Maybe you want additional capability in your firewall, such as deep packet inspection, or additional processes within your personnel selection, which does more detailed vetting of possibly new staff. So there are things that you can do within your environment to further secure your environment once you have these basic steps in place. And then monitor and maintain. Once you put all these things in place, you want to make sure that they stay there and that you stay secure. So again, as I mentioned, we have a course that goes through, spends a full day discussing details of all these items, but just as a basic set of steps, all organizations must go through all of these steps in some fashion to secure their environment, and your cybersecurity management system will cover all of these areas and describe and provide you with policies and work instructions and details as to how your particular organization is going to implement all these things. So as an overview of your cybersecurity management system, what are you doing first? Well, you're doing that risk analysis to determine what your assets are. Do you have safety systems? Are there internal records, control functions, perhaps corporate secrets that you want to make sure that you protect? What are the things that are most valuable to you? And how do you maintain and manage access to those assets and make sure that they are protected? There are a variety of resources available to you in terms of existing documentation, such as the 7 Steps course that I mentioned, or the standards, both the 62443 and the NIST Framework guidelines. And there are others out there that can help you if you have more specific problems and specific concerns. And then you always want to make sure that once your system is placed, you have clear means for getting feedback on how well that environment is working. Once you get it set up, you can't just leave it and hope that it runs. You have to continuously monitor that system and practice things like backup recovery, or practice things like other security breaches, to make sure that everyone involved knows what to do and how to address those if they in fact occur. So you want to recycle any metrics that are gathered back through the entire process in terms of making sure that you understand what to do, what you can do in terms of improvement. And as with setting up all systems, there are barriers to success. There are roadblocks. I'm sure that there are many of them that you can individually identify if you've started this process at all. Probably one of the largest ones and most serious ones is personnel training. People must understand their job and have the skill set needed to do those jobs. As I mentioned before, misconfigured security equipment might just as well not be there. You have to have a clear picture of what your assets are and your network configuration. I can't tell you how many installations I've looked at, and there are marked up drawings that I receive, and people kind of point me to closets and dust areas saying that, well, I think there are a couple of servers over there, but I'm not quite sure what they're connected to. No, you have to have a real clear picture of what's going on, and then you have to monitor that to make sure that it is what you think that it is. Intrusion detection systems will help you do that. Tools like Wireshark, you can connect those to your system and get a good, clear picture of what communications look like, and just make sure that they agree with what you think should be out there. And of course, there's the conflicting priorities, which we started out with. Any organization that has manufacturing or process kinds of environments will have conflict. Hopefully it's not significant, but conflict with general IT departments. You have to work together. You can't blame each other when attacks occur, but because the attacks impact all aspects of the organization and the profitability of the organization. So here are just some quick examples. You probably have heard of most of these. And I guess I'd maintain that a good cyber management system was not in place, or at least maybe one was, but they had some significant holes. You've all heard about the Yahoo accounts. Supposedly 1 billion accounts were compromised. LinkedIn had 160 million. The retailers, Target, Sony, and Home Depot have all lost account information because attackers have been able to infect and get into their systems. Lockheed Martin potentially lost design details on a fighter jet program. Not a good situation. There's a German steel mill that 2 years ago was subject to a spear phishing attack. This is something where users within the system were deceived into providing login and security information to obviously an attacker, an unauthorized user. That kind of thing really only occurs if your staff and personnel are not really cyber aware. Any kind of access to or request for information regarding passwords or authentication always is managed through some kind of a separate tool, never through things like email. Way too insecure. The Ukrainian power grid was attacked. A kill disk virus basically bricked a switching station. When you say something is bricked, you basically turn it completely inoperative such that it needs to be turned off and turned back on and rebooted. And then they experienced the same kind of attack around a year later. So here it happened once to them. They did not get a good cyber management system in place, and it occurred again. Stuxnet, I mentioned earlier. There are some great books and articles on Stuxnet, and it caused a direct failure of process equipment. I mentioned before the German steel mill. They lost control of a blast furnace, and there was significant equipment damage there. National laboratories within the U.S. Had some communications disrupted, and supposedly Pentagon files were compromised, but they won't tell you what they lost. So anyway, these are all examples of where people perhaps thought they had good cyber security management systems in place, but reality showed them that they were still compromised. So overall, in conclusion, systems can be compromised. There can be personnel and equipment injury that occurs. Technical information, so that's really what should motivate you in terms of getting a good cyber management system in place. Once you do, that cyber management system guidance is available from a variety of resources. We talked specifically about 62443 and the NIST Framework. TR 8409 is also a good source of understanding the relationship between functional safety and cybersecurities. You have to recognize that all systems are vulnerable to attack. The means of attack is constantly changing, so you always have to be vigilant in terms of understanding what kinds of attacks have occurred and seeing whether or not those in fact could potentially occur to your environment. You must have a good handle on your assets and your network, and they all have to be carefully managed, and personnel must have the necessary skills and a cyber mindset. You know, if there are necessary skills to do their job, and an overall mindset that says there are just some activities which are completely forbidden when it comes to any kind of a network environment. So every system with a connection to the outside world will experience an attack at some point in time. Having a good cybersecurity management system in place will provide the means for mitigating and recovering from that attack. So I'd like to thank you all for your attendance here. Let me open up the floor for some questions. See if any have come up here. There is a question here. Is CSMS different from ISMS, Information Security Management System, as defined in ISO 27001? Well, information security management, yes, certainly deals with managing data within your environment. I tend to think that that would be a little bit more focused on IT environments, which have different priorities than operational environments. So the focus of this presentation was on manufacturing environments, operational environments, not strictly IT environments like banking perhaps. You do need to have address both sides. So ISMS is good for information security, but in a manufacturing environment, you really need to understand the potential attack on assets within your environment. So I see some other questions here dealing with the sizing for different organizations. Yes, obviously, larger organizations have more funds and money available to do larger management systems. Certainly, you have to determine the value of a potential attack or the cost, let's say, and determine what your activities are commensurate with that. I don't know how else to put it than that. It all has to be sized based on what your organization considers to be at most risk. So here's a question that says, should CSMS be part of IT admin or part of control system admin? Well, it's not a matter of one or the other. It must be both, and both have to meet on a regular basis and not fight. They have to be able to work out the differences. IT may want to say, oh, we want to roll out these updates to switches and servers, and they just roll this out, and suddenly the operators lose visibility on the process. So there's no way that IT can manage the rollout of server updates without the specific interaction with the operational environment. So it's not a matter of one or the other. Both have to be involved, and the best case scenario is the team. You pull members from each team and work together on finding a best joint solution. There's a note here. We assume that serial communications is not prone to attack. It's less likely that, I showed an RS-232 connection to I/O. It's less likely that an attack will occur through that, but it's something that you should consider because it is a potential way into your system. Can encrypted emails be considered a secure means of communication? It's a step, but I certainly would not pass critical information through even encrypted email, and certainly nothing like any authentication information. Users, that kind of authentication and management always needs to be handled by an independent system. So even encrypted, I would not consider that that's certainly good for maintaining security of company information in general, but not in terms of specifically managing cyber aspects of your environment. Let's see here. There's a question about security levels that came up. Security levels are something which are defined in the 62443 standard. They're somewhat controversial. 62443-3-3 attempts to associate security levels with the means of attack. So the question then becomes, how much money do I have to spend in order to secure myself from that attack? And there just really isn't a good answer. Actually, I'm providing a presentation at Texas A&M next week that tries to explore that. It's kind of a workshop. Hope to get some ideas from folks on how they address that particular problem. If you can make it down to Texas and join us at Texas A&M, Exida will have a booth there, and you can come in and participate in the workshop. Let's see here. How much established, recognized is the Exida CACE certification? So this is our cybersecurity certification. That's sort of the counterpart to the safety certification. It's widely recognized. ISA Secure, I didn't even really mention ISA Secure at all in this presentation, but ISA has a whole set of standards that are involved in cyber certification, and they list as one of their training criteria the CACE certification from Exida as one that demonstrates a clear understanding of networking and cyber-related concepts. Let's see, is it realistic or even practical to implement a CSMS only concerned with safety integrated system logic solver and not the process control system, even if they are integrated? Well, certainly the most important thing for you to do is protect that safety system. Then along the way, you should be able to manage or be able to leverage some of that protection for your basic control system also. So certainly if there's limited funds, you want to protect the most important things, and in a manufacturing environment, the most important thing to protect would be your safety systems. Certainly you want to protect your basic control systems also, but safety systems are the top priority item. Looks like that pretty well closes it out. If you do have any additional questions, please don't hesitate to contact Exida. Again, my contact information is djohnson@exida.com. Here is a quick list of just a few of the courses that we have coming up that are related to cyber that are being taught here in Sellersville, and we have the 7 Steps class that's going to be down in Texas. Please, if you have any interest in these, contact our training group or send me an email if you have any specific questions. And also, we have a wealth of information on our site. There are many, many other training opportunities in both safety and cyber. I'd encourage you to take a look at those. We are going to be, as I mentioned, at Texas A&M next week. If you have any opportunity to stop by, please introduce yourself. I'd love to talk with you and find out how you are viewing and managing your cyber-related challenges. And then, like everybody, we're on Twitter also. Please, contact us through Twitter, or better still, if you have any suggestions for these webinars. Like I say, we conduct these on a weekly basis. There's a tremendous amount of enthusiasm for these webinars. We generally have a very good turnout. Lots of good discussions are spurned or come out of those, spawned from those conversations. So again, let me check once more for any additional questions that have come up. Thank you, thank you. Yes, thank you for attending. So again, please visit the Exida website. Send me an email, djohnson@exida.com, if there's any further questions that I can answer for you. Those that are attending the presentation will receive a PDF copy of this. And again, I thank you very much for your attendance and participation here. Bye. Bye now.